So now that we've learned what a mole is, we need to think about why does it matter? How are we going to use it? Well, you can use a mole to convert between grams and particles. You can't compare grams of two different substances because we know that the individual atoms have different masses. However, if you can convert it into moles, you can compare moles of all different kinds of compounds. So we need to learn how to convert between grams and moles and particles. So just a reminder, a mole is a word that we use like we use the word dozen. When we say we have a dozen of something, a dozen donuts, we know that we have 12. We have 12 donuts. If we were to say we had a mole of donuts, we would have 6.022 times 10 to the 23rd donuts. It doesn't matter what the substance is. If you have a mole of it, you always have 6.022 times 10 to the 23rd numbers of those items. So let's look at our first requirement. Before we can do any of these conversions, we need to know how to calculate molar mass. And we've done this a little bit already. We know that the molar mass is the mass in grams of 1 mole of a substance. If we have 1 mole of hydrogen, it has a mass of about 1 gram. If we have a mole of carbon, it has a mass of 12.011 grams in 1 mole. So grams per mole are the units for molar mass. That number for carbon comes right off the periodic table. So remember, this bottom number on the periodic table is either your mass in AMUs of single particles or single atoms, or it's the molar mass in grams per mole of a mole of that substance. So the number under carbon, the mass number, is 12.011 grams. If we're talking about the molar mass, we can say that it's 12.011 grams per mole, or 12.011 grams in 1 mole of carbon. If we wanted to find the molar mass of ammonia, NH3, we'd have to find the molar mass of nitrogen, plus we have 3 hydrogens. So nitrogen we get from the periodic table is 14.007 grams per mole. And then we have 3 hydrogens, and hydrogen is 1.0079 grams per mole. You add those all up, and you get about 17, I think it is exactly 17.03 grams per mole. That would be the molar mass of ammonia. I got these two numbers right off the periodic table. So there's nitrogen, 14.007, and hydrogen, 1.0079. So you can do that with any type of chemical formula, because your chemical formulas tell you how many of each type of element are present in that compound. So you can just add up all of the different values and come up with a molar mass. Now I want to point out a different type of compound that we haven't seen yet. It's a special compound called a hydrate. Now we think when we hydrate, we are adding water to our bodies, we're consuming water. This is very, very similar. A hydrate compound is just a compound that has water chemically bonded to part of the compound or one of the elements. And you know this by this dot right there. That tells you that this is a hydrate. So we have CuSO4, copper 2 sulfate, with 3 waters. So if we wanted to find the molar mass of this, we add up all the pieces. So we have a copper plus a sulfur plus 4 oxygens plus we have 3 waters, and each water has 2 hydrogens and an oxygen. We could also think of this as 6 hydrogens, because 3 times 2, plus 3 oxygens, 3 times 1, just distributing that 3 through that. So we still have our 4 oxygens, sulfur, and our copper. Once you pull all these numbers from the periodic table, you get a value, let me look at my cheat sheet, of 213.6 grams per mole. So that's adding up the molar mass of copper, sulfur, 4 oxygens, 6 hydrogens, and 3 more oxygens. It works the same You just have to know that this dot is adding these waters to the original compound. Now, let's talk about how to convert between mass and moles, so grams and moles. If we have 20 grams of ammonia, how many moles do we have? If you're going to do either of these conversions, you need the molar mass. So the molar mass of ammonia we calculated earlier is 17.04 grams per mole. So if we have 20 grams of ammonia, that's what we're going to start with. If I set up my factor, this is where dimensional analysis comes in. I have grams up here, so I'm going to put grams down on the bottom. And I'm going to moles, so I'm going to put moles on top. My grams cancel. I know for ammonia, I have 17.04 grams in 1 mole. So that's where the molar mass comes in. in 1 mole, I have 17.04 grams. So if I do 20 times 1 divided by 17, I get 1.17 moles of NH3. Now, I want to point out something kind of silly right here. I didn't forget to add the E. The abbreviation for mole is MOL. I don't know why, it just is. That's how you'll see it frequently written. Likewise, if we want to go backwards from moles to grams, we again need the molar mass. So any type of conversion between grams and moles, no matter which way you're going to use the molar mass. Here we have 3.5 moles of carbon. Set up my conversion factor. I have moles on the top, so I want moles on the bottom. And I'm going to grams because it's asking how many grams. For carbon, if I look on the periodic table, there are 12.011 grams in 1 mole. So that's the molar mass. Multiply 3.5 times 12.011 and you get 42.04 grams of carbon. So that tells me if I have 3.5 moles of carbon, I have 42, essentially, grams of carbon. So now we know how to go between grams and moles, mass and moles. Let's look at how we can go between moles and particles. To do this conversion, you need Avogadro's number. And that's the 6.022 times 10 to the 23rd. So you're only going to use 6.022 times 10 to the 23rd when you're trying to figure out how many atoms, how many molecules, how many particles of something you have. So we're starting with 3.5 moles. If I set up my conversion, I have moles on the top, so I want moles on the bottom, which means I want particles on the top here. Now, you have to ask yourself how many particles are in a mole. That's where your 6.022 comes in. There are 6.022 times 10 to the 23rd particles in 1 mole. When you multiply 3.5 times 6.022 times 10 to the 23rd, you get 2.11 times 10 to the 24th particles. You have to be very, very careful here when you do order of operations. When you type this into your calculator, I suggest always putting this guy, that whole thing, in parentheses, just to make sure that you're not accidentally multiplying things or dividing things before you intend to. If we're going to go the other way, from particles to moles, again, we need the 6.022 times 10 to the 23rd. That's Avogadro's number. So if I have 5 times 10 to the 24th particles, set up my conversion, I know I'm going to put particles on the bottom, because that's what I have on the top up here, which means I'm going to moles, so I'm going to put moles on the top. Now, again, you have to ask, how many particles are in a mole, or how many particles make up a mole? So in 1 mole, we have 6.022 times 10 to the 23rd particles. When I divide those two numbers, again, be very careful with order of operations. I would suggest putting parentheses around everything. You get 830 moles. I want to point out a couple things. First of all, when we do the conversion between moles and particles and moles, in neither of these problems did I specify what substance we were looking at. It doesn't matter. A mole of oxygen is going to have the same number of particles as a mole of water, which will have the same number of particles as a mole of silver nitrate. It doesn't matter what the compound is. If you have a mole of something, you always have 6.022 times 10 to the 23rd particles. Another thing I wanted to point out, in all of my conversions so far, the 1 has always been with the mole. We talk about how many particles are in 1 mole. We talk about how many grams are in 1 mole of a substance. So your 1 is always going to go with your mole unit when you do your conversions. So the last scenario I want to look at is if we want to go from grams all the way to particles. Now, we don't have a conversion to do this. We can't go all the way from grams to particles. We need to go from grams to moles, and then from moles to particles. We don't know how many particles are in a certain number of grams. We only know how many particles are in a mole. So this is going to be a two-step conversion. So we're going to start with what we have. We have 5 grams of carbon. Now, to go from grams to moles, I'm going to put my grams on the bottom so they'll cancel. That leaves me with moles on the top. Now, if I see these units, grams and moles, I know I should be thinking molar mass. And the molar mass of carbon is 12.011 grams in 1 mole. That comes right off the periodic table. My second conversion is going to be from moles, so I'm going to put that on the bottom so it cancels, to particles. And we know that in 1 mole, we have 6.022 times 10 to the 23rd particles. This, when I see this conversion, those units, we know that this is going to be Avogadro's number. That's the 6.022. Now all I have to do is solve. So I have 5 divided by 12.011 times, make sure you put parentheses when you plug it into your calculator, 6.022 times 10 to the 23rd, which I can't remember off the top of my head, but my cheat sheet says 2.5 times 10 to the 23rd particles. So in 5 grams of carbon, we have 2.5 times 10 to the 23rd particles, or carbon atoms. What if I want to go the other direction? Particles back to grams. Well, we can't do that either. So same as the last one, we have to go from particles to moles and then up to grams. So this time I say I have 1.2 times 10 to the 24th particles. I know I'm going to go from particles to moles, so I'm going to put particles down here. So those go away, which leaves me with moles on the top. You should be thinking your 1 goes with your moles. What number goes down here? 6.022 times 10 to the 23rd. Now if I'm going to set up my next conversion, I'm going to go from moles to grams. So moles to grams. So my moles go away. This set of units should be telling you molar mass. H2 is going to be 2 times 1.0079 grams per mole, because we have 2 hydrogens, which gets us 2.0158 grams in 1 mole. Now again, we're back to math. 1.2 times 10 to the 24th divided by 6.022 times 10 to the 23rd. That's a 3. Make sure that you're making your calculator follow order of operations, and then times 2.0158, and we get 4.02 grams of hydrogen. And that's how we use the mole to do our conversions between moles and particles, particles and moles, moles and grams, grams and moles, or to go all the way from particles to grams or grams to particles. You have to go through the mole. To do that, you're going to use the molar mass if you're using grams, or you're going to use Avogadro's number if you're going to particles.